Alright, so this should be video number 2, and we're carrying on from problem number 12. Sorry, not problem number 12, problem number 10. And I've got 12 equals the absolute value of x minus 5.4. So the absolute value is already by itself, which is step 1. There's nothing outside being added to it or being multiplied to it. So I can set up case 1 and case 2. Case 1 is going to be just to drop the absolute value. You can leave everything else the same. X minus 5.4 equals 12. Add 5.4 on both sides. And we're going to get x equals 17.4. And I've discovered a new problem. The pen is skipping. Alright, case 2 is going to be the opposite of what's in the absolute value. So x minus 5.4 equals negative 12. I would add 5.4 to both sides to get my x by itself. And I'm going to get x equals negative 6.6 rather. And I can leave that as the way I'm going to leave my answer, or I can use braces When we use braces in math, it means that we have a set of things or a list. All right, let's take a look at number 11. Number 11, we cannot just jump to case 1 and case 2 because I have something on the other side of the equal sign. I've got this 12. All right, so I'm going to subtract 12 from both sides, and we'll get the absolute value of g plus 6 is equal to negative 8. Well, we're encountering a problem now because absolute value cannot equal a negative number. So I don't need to set up case 1 or case 2 for number 11. I'm just going to tell whoever's grading this that there are no solutions for number 11. We can use our symbol for the empty set, or I can just simply write no solutions. Now this pen is getting worse. Alright, let's take a look at problem number 12. With number 12, first step I would take would be to distribute the 2 into the parentheses, because we can't bring anything into the parentheses other than that 2. We can't take anything out of the parentheses, so I'm going to get rid of the parentheses. So 2 times x would be 2x, and 2 times 5 is 10. From the other side, I'm just bringing everything down. We haven't changed anything. And next step, I want to gather my variables to go to one side of the equal sign. So let me subtract 2x to get rid of it on this side. Subtract 2x on this side, and we've encountered another issue because the x's are all gone. And I'm left with negative 4 equals 10, which of course is false. So when the variables drop out like that and we're left with a false statement, that means no solution. So again, we can use our symbol for the empty set, or we can write out no solution. We're going to take a look at some inequalities. For the inequalities, we want to, it's almost the same idea as the equations. I'm going to get the variable by itself. And if I can do that, I can say what the variable is allowed to equal. And it's not going to be one number, it's going to be a group of numbers. All right, so I get t is less than 7 by subtracting 3 on both sides. For a number line, if your variable is first in your inequality, like it is here, t is first, t is less than 7, then that inequality is going to point the direction we're going to shade. Alright, so I'm going to close the circle and shade everything less than 7. We can put a couple numbers over here. 0 is less than 7, and one number over here, 10 is greater than 7, so it would be on that side of the number line. To express my answer in interval notation, I am going to go from negative infinity to 7. Since we're including 7, I'm going to use a bracket. All right, let's take a look at another inequality. P over 4, or P divided by 4, is greater than 2. In order to get the variable by itself, I'm going to multiply the numerator by 4. And I'm going to multiply the other side of the inequality by 4. And I get P is greater than 8. On a number line, I've got 8 in the middle. Our variable is first in our inequality, so it's going to point the direction that we're going to shade. So I'm going to shade everything greater than 8. I'm not going to close the circle. I'm not going to shade in the circle because I don't have the equals bar underneath that inequality. All right, let's take a look at number 15. I want to get the k by itself, so I'm going to divide both sides by negative 2. One thing we're going to encounter here is the major difference between dealing with inequalities versus an equation. When we divide by a negative number, we have to switch the direction of our inequality. So I'm going to have 14 divided by negative 2 is negative 7. Negative 2 divided by negative 2 cancels, and I'm left with k is greater than 7. On a number line, I'm going to put 7 in the middle, negative 7 rather. On the left of negative 7, I can put a number like negative 10. That's the direction is more negative. On the right side, maybe 0. All right, to shade the greater than -7, I'm going to go this direction, and I'm not going to close the circle because there is no equal bar underneath the inequality. For interval notation, if we look at our number line from left to right, I'm going to start at -7, and my solutions go on forever. We're going to have a parentheses next to the -7 because it doesn't include it, and a parentheses next to the infinity because we can't include infinity. Alright, I'm going to go ahead and stop the video now, and we'll do a third clip for the last few problems.